Hi, welcome back to another video of learning C++. So in the previous video, in this lesson 9, we started the topic operator overloading. So basically in operator overloading, we overload the functionality of operators for our specific user-defined data types like structure or objects of the classes. Okay, so in this video we are going to learn about the binary operator overloading. In the previous video we learned about the basics of operator overloading, the syntax for it, and to be more specific, the unary operator overloading. Now in this video we will learn about binary operator overloading. So what do we mean by the binary operator overloading? Now binary itself, by means two. So what happens here, that previously what we were dealing with was that only one value or one variable. For example, I would have had variable 1 plus plus or variable 1 minus minus. So this is like unary operator, because unary operand, one operand. Okay, so variable 1 here, variable 1 over here. Now what do we mean by binary operator overloading? In this we can make use of variable 1 plus variable 2. Okay, and then you can write 10 plus variable 1 as well. So this is basically the binary operator overloading, in which you uh, operate over two operands. Okay, so one can be a constant, another can be an object, or both can be objects as well. So basically what are then binary operators? Like plus sign, you can add two things, multiply, minus, divide, or any other. And let me tell you one more thing, that the following operators cannot be overloaded in C++. Scope resolution cannot be overloaded. Also, you cannot overload this ternary operator as well. You can also not overload the accessor to the members of the class dot operator, and also dot steric operator as well. So these four operators cannot be overloaded. Okay, one more thing, that equal sign is already overloaded, like this, that we did in our last video, that we copied one value to another object value. So this was basically the use of equal sign. So it can be overloaded as well. It is already overloaded. It just detects whatever you do, and it copies one data into another object data by itself. So I guess you guys got the basic idea of which operators can be overloaded and what is meant by binary operator overloading. All right, so the first thing that we have to do is to make changes to our already designed operator overloaded functions. So in this way, you will also differentiate in the syntax, as well as you will learn better, because this is the same example that we implemented in our last video about unary operator overloading. Now, the first thing that we are going to do in this is that we have to change some things in our function as parameters. What is that? For example, here I told you in my previous video that suppose this, it is acting like a function. So when you have one variable and you are just applying the function over it, that plus plus, so the function already knows, the member function already knows that I am talking about a certain object. For example, if this function was called, if this function, just talk in the terminology of function, if this function was called for object 1, so the compiler already knows that whatever the A is, it means that it is object 1. Okay, so here is there is no any other object, so there is no confusion. But when you are dealing with two objects or one object or another constant, you must define them. You must tell the compiler which object is which. Okay, so for that reason we are going to receive a parameter over here. So the parameter is going to be obviously of the class type. So the class name here is the operate, and then we will create a temporary object. Okay, so temporary, instead of just temp, we will write temper, which means like a temporary receive parameter. Okay, so just to differentiate between a temporary class created and a received class. Another good practice is that is preferred in operator overloading, that we use constant keyword. Okay, so basically what does the constant keyword does, that whenever you declare something with a constant keyword, it cannot be altered in your program further. Okay, it can be only used but cannot be changed. So it's good practice to use a constant keyword. So in this way you cannot temper the data which you receive. One thing, another thing, maybe accidentally you may uh, alter the data. Okay, so the copies have no effect on the data change. For example, if you change the data of this temporary r, it will not change the data over here, because we already know that whatever is created as parameter is the copy. So the constant is a good practice in a case when you use a reference. Okay, so when you use reference, when then what's happening, that you have access to the address of that object. So whatever you change over here, it can be seen in this object as well. So then it's very good practice to use a constant keyword and a reference. And this syntax is more preferable. I will tell you why. Because there are a few advantages. One, data can't be changed due to constant keyword. Another advantage is that instead of creating copy, when you create a copy, the space is allocated more to the object as well. So the optimized way, the best and efficient way is to reference it. So due to reference, you are not actually creating a copy. Basically, you have the address of the actual object where it is located. Okay, so this is the most efficient way of doing it. Otherwise, if you want to do it in simple way, it will work like this as well. But I just wanted to tell you about the most preferable, and you will see a lot of this kind of syntax in operator overloading. So we will follow this syntax. Now next thing that we are going to change is the operator, because the increment is basically used, or decrement, these double plus or double minus, these are basically used as unary operators. So a single plus is a binary operator, a single minus is a binary operator, or division multiplication is a binary operator. So the first thing we are going to start with a simple operator, that is a plus sign. So up until now what we have done is that we have changed our operator as well as the parameters. Instead of empty parameter, right now what do we have here? We have some receiving parameters in the form of reference, or you can create a copy of the values as well. Okay, so what's the next step is going to be? So the first thing that what we are not going to change is this operate temporary object, which is this one, because we still want to return the object. Okay, the class object, the respectable class which is operate in this case. Now temporary dot a will also remain the same. The only thing that is going to be changed is this side of the expression. What do we want to have? First of all, as I told you before, that the compiler already knows that what kind of member we are talking about when we deal with just one object. Okay, so for example, when before this, when I called this function, so for example, if I called it for object 1, so it knew that it is object 1. Now what we are going to do, we are going to call it for two functions, actually for two objects basically. One is this receiving parameter and another is the object for which it is called. Okay, so there are two variables. One is the member of the object itself, which is going to be a. So a belongs to the object for which it is called. For example, if this operator overloading is called for object 1, then this means that this a belongs to object 1. Now another a that has to be added with this member variable according to our situation, that is this receiving object. Okay, so which is in this case temper dot a. Now what do we have here is that we have added the a value of object 1. This demonstrate the object 1 because we are not using any accessor like temper any object. So this means that it is calling for itself. Okay, and this is temper.a, which is this parameter, this reference object that is going to be passed from our main function. Okay, now let's see what happens in our main function. Now before this we were unable to add two objects. Now what we can do basically is that we can actually directly add two objects. So for example, I would like to have another object, operator object 3. Okay, in object 3 I will store the data of object 1 plus object 2. Okay, and then let's display the object 3. So the expected result is going to be what? 20, because two objects, one object is 10, another object is also 10. So as you guys can see that we got a successfully 20 result. So what just happened over here? Let's just revise it. So I will do the same thing for you guys, just we used to do it with the previous tutorial. That for example, we have predefined data type as integer, and we have a is equals to 10 and b is equals to 20 or 10 as well. And then we have another variable as c, and we do the c is equals to a plus b, and then we print c out c. Okay, so let's print out the result. So we have a is equals to 20 and c is equals to 20 as well. So here this is the same thing that's happening over here. So integer, instead of integer, what do we have here? We have operate keyword, because the user defined data type name is operate, so the data type name here is integer. Here we have the variable that is instance of the class is as object 1, which initialize its member a with 10 value. So what is happening here? The same. And also our b is our object 2, because it also initializes its member variable with 10 value as well. Now we have an empty variable which has no data in it. So is the case over here, object 3. Okay, so what we are doing, that object 3 is equals to object 1 plus object 2. Now let's have a look in the operator overloaded function. So what is object 1? Let's say that this function is called for the object 1. Why? Because you do not have to look at this. Just remove this object 3 for now. Just remove this object 3. First of all, let's talk about this object 1. Object 1, it knows that it is object 1. After that, it calls for this plus. Due to this plus, what we are doing, that it is calling this function. Okay, so object 1 has called its member function, that is operator plus. Okay, just suppose it like this is a plus function. Okay, its name is plus. Okay, so we have called a function which name is a plus. So object 1 has called the member function plus. Now it has added object 2. So it is your argument passed. It is your argument passed, which is also received over here. Now what's happening within the object itself, within the function itself, that we have a temporary class as operator, and then we have temp.a. So it is a temporary class, it is not a received class. Okay, so we have created a temporary class with a member variable a. Within a, what we did, we added two values. One is this a and another is temper.a. So what is a and what is temper.a? So a basically demonstrate that it is object 1 value of a. Okay, object 1 value of a, and basically temper.a is equals to object 2 value of a. So you got the idea. So what is happening, that object 1, due to plus and due to object 1 before the plus, it called this function. Then we received object 2 as our parameter over here. Then it added its two members. So there was no need to write anything to access the member of object 1, because we already know, the compiler already know we are talking and we are dealing with the object 1. So we just wrote a as it is, and then here we wrote it temper dot a just to have the value. Then we return the temp. Now as we have returned the value as what? Temporary. And temporary is the object of class operate. So we should receive this value in a class, in an object that is related to the same class, that is the instance of the same class. For example, operator object 3. Okay, so that is our third class. So object 3 is equals to, so just like C is equals to A plus B, it was integer of the same data type. So object 3 is of the same data type and it is receiving addition of two variable. You can also get A is equals to A plus B, A is equals to A plus B. So in this case it is going to be object 1 is equals to object 1 plus object 2. So you can print the object 1 and its value will be 20 as well now. Okay, we are doing this 2 time. Okay, just run this program now, and as you guys can see that we have got 2020. So I hope you guys got the basic syntax idea and how its a working principle is, okay, of a binary operator overloading. Okay, now let's talk about adding some constant value to our member of the certain object. For example, instead of adding a complete object to my object, if I want to add object 1 plus 10, so it will not work. Why it will not work? Let's have a look. It will not work because what you are doing whenever it calls this plus function, what it's expecting from us is that to send a variable that is of an integer, of the class type operate. But what we are sending actually is 10, which is an integer. So I'm expecting that you guys already know what I have to do. So guess it now, and I'm going to implement it in my this function. Okay. So the thing that we want to have is that we want to have a constant integer. So the same syntax, constant integer, and let's say and we will say r just to tell you that it is a receiving parameter. Now everything remains the same, operate temporary because we are going to return the temporary. Now what do we want? A belongs to the same object, so we do not have to write object 1 dot a. So instead we are just writing a because the compiler knows that we are calling this function for the object 1. So the member is actually of the same object. Okay, so a plus the r received. Okay, now let's return this. Okay, let's see will it work or not. As you guys can see, we got the same result. What's happening over here? That this function, this object, when it is used with this plus operator, it is calling this function, this operator overloaded function. It calls this, then it receives this 10 as its a parameter. So when it receives this 10 as parameter, then it just adds it to the member variable. So here you are just doing it the simple integer way that you are used to do it. You just add two simple integers. Okay, so this is the concept and syntax for adding a constant value in this manner. Now one more thing, let's say I want to have object 1 is equals to 10 plus object 1. Okay, so what does this mean? Technically what's like, so if you do a plus b or b plus b, a 10 plus a or a plus 10, technically it is same, mathematically they are same, but for the program they are not same. Okay, so this will not work, this program will not work. Okay, it will give us an error. As expected, it is giving us error. So you will ask me a question now that why this one is not called for it, because for this methodology you have some separate syntax. Why separate syntax? Just to get you guys in this concept in a simple word, in simple wording, that is, Whenever you use this syntax, object 1 plus 10, what it means that the compiler knows that the function that is going to be called is for object 1 and the receiving parameter is 10. Okay, so that's done. So when you are doing 10 plus object 1, what's happening? What's happening that the integer value is basically before the operator and before the object. So the things that are received here is now a bit different story. So now with the help of one concept that is called a friend function, due to which we can do this. So for example, I will just copy this whole code, copy this, and we will paste it over here. And I'll tell you what specific changes you want to have. The first thing is that you want to use friend. Okay, the friend keyword basically demonstrate that this is a friend function, and if you define it outside your class, you can access the member values of the same class, just like the member functions that we discussed earlier, that if you want to declare the member functions within your class and then define them outside the class, you can access them. So this is basically the same kind of concept, that friend keyword lets the function access the values of the private members of the class outside the class as well. Okay, so first thing is going to be the friend keyword, and next thing that you are going to do is to write the constant integer here as well. So you will write integer AA, or we can write it as R. Now what do we have here is that it is going to expecting that we are going to receive one constant and one object. Okay, then next thing that we are going to do is that we will add R with what? With temper dot A. Okay, then let's call this function. So as you guys can see that we successfully implemented the code and it's working totally fine. So what's happening over here, that first of all, when this 10 is encountered, so compilers until now it knows that it is just a simple 10. Okay, after the 10, what happens that a plus is called, and along with plus it is not a simple value, it is an object. Or we can say that we are actually storing some values, some calculation within our object. So the expression knows that we are dealing with the object of type operate class. Now what it does, that whenever we use 10 plus object 1, so it is expecting 10 as our first parameter and object 1 is our second parameter, as in the case here as well, that constant integer R is our first parameter and constant operate and temper is our second parameter. You can use and over here as well. So just for demonstration, if I just change its sequence, cut, and I write it over here, it will obviously going to give me error. Okay, so let's run this code now. Why it's giving me error? Because it is expecting 10 as our first parameter, and in this case the first parameter we just change from integer to class and second parameter as 10. Okay, so I am expecting if I use object 1, okay, just simple can be like we will just comment this code and let's run this one. Will it run or not? Oh, sorry, build and run. Yeah, it runs. Okay, why it runs? Because the first parameter is object 1 and the second parameter is this R, and also we have designed this one for this operation as well. So now I'm expecting you guys have learned about the binary operator overloading syntax. Okay, so this is very good. And one more thing, that for students, that this is oftenly asked in exam, that they will give you some sort of classes there and they will tell you that to add 10 or any other constant value with your object. So what happens, that students always design this operator overloading function and it is incorrect. So let me tell you, the syntax for performing this kind of operation or expression is to use this friend approach. Okay, friend function approach. So I hope you guys have learned about binary operator overloading. Now what we are going to do from our previous tutorials that we modified in our last tutorial as well, the time class. In the time class, what we had here is the add function, in which two functions were passed and they were added. So it was like a bit difficult syntax, a bit unusual scenario that you have to call a function in order to add to time. Now we will make use of operator overloading concept in this time class, and we will modify and we will have another function in our time class for our plus operator. So let's have a look. So first of all, I'll just copy this whole code so that the things that should not be rewrite again will not be reprogrammed. Okay. And the next thing that we are going to have is the plus, and first thing that we are going to receive is the constant, and we will have a time, we will have and we will have a temper. Okay, temper. And then what we are going to do, we are going to have r's plus temper dot r's, and same is the case over here as well. So we will do minutes plus temper dot minutes, and then what we are going to do, okay, we are going to write plus temper dot seconds as well. Okay, and the days should be added as well, so we will write temper dot day as well. So what we have just done over here is that let's just demonstrate it over here. Let's say we have two times like time 1 and time 2, and we will have 12, 56 and 78. Okay, these are two times, and we will have another empty time with 0 values, so time 3. All right, and what we are going to do, we are going to write time 3 is equals to time 1 plus time 2. Okay, so we will display the time 3 over here. And remove this code. Let's run this code. All right, so as you guys can see that both the times have been added. So first of all, let's have a look. 12 plus 26 is equals to 38. 38 minus 24 is equals to 14, and 14 minus 12 should be, is it correct or not? I don't know if it is correct. Oh yes, because due to these minutes, the R's have increased by 2 as well. So it's working. Okay, so just by using plus sign, we have added two classes. Before this, we had to call the function, the add function for it. Okay, now you can add two objects just simply in a way that you do like A plus B. So it is very useful. Now you can add two objects of the same class, you can multiply two objects of the same class, you have to just modify the code within the operator overloaded function. You can divide two objects of the same class, you can do whatever you want to do. You do not have to write the whole name like add, multiply, or calling the function or using dot operator. You can just write time 1 plus time 2. Okay, just simple like A plus B. Okay, so for your homework, what you are going to do, you have to modify, I expect you that you have already made this whole class. You have to modify it in order to add more R's into your time class. Okay, so this is your homework. So I guess you guys have learned about the basic syntax and understanding of binary operator overloading. In the next tutorial of this same lesson, what we are going to perform is the practice problem, and the very famous practice problem that is oftenly discussed as distance class in OOP. So we will be going to implement that, and we will use the operator overloading concept in that class as well. Until then, goodbye.